Okay, amazing. So I think we might have everyone here who is going to be here. So I think we'll probably just get started. So in the Zoom room, you're going to see Mitch and Martin. They are going to be your helpers. So if you get stuck, send a chat to the Zoom, and they will work with y'all to try to fix the bugs, try to fix whatever's happening that isn't working. And then in the room today, we have Courtney and Ronan, and they're going to help with the in-person workshop. And so essentially what we're going to do today is just talk briefly about reproducibility in science, and also about what it means to use data repositories, and also what version control is and why I choose to use GitHub and a lot of people choose to use GitHub. The first thing though that I need to make sure that everyone has done is to introduce themselves to Git and GitHub. So if you are in our studio, you can actually just run these lines of code, and you're going to obviously want to replace your username with your name that you made on GitHub. So this is assuming that you've already created your GitHub profile. And also some of you probably already did this prior to this workshop. So you're going to replace it with your username on GitHub. So mine is BLShum. And then you're going to also replace the email with the email you have associated with your GitHub account. So if everyone could just make sure that this has happened for them, and then if everyone could give me like a nice thumbs up type thing. Okay, awesome. Claudia's got it. Sakshi's got it. Jim's got it. Kram's got it. Okay. And then, yeah, once Val and Christina, you have it. Just, I know. Good. Thumbs up. Okay. Yeah, and that's something if you haven't introduced yourself. Oh, yeah. So if you already introduced yourself via the command line, you should be good to go. This is just to make sure that we can now use GitHub and the Git RStudio interface today. So perfect. Okay. So first, I just want to talk about why GitHub. Or why version control. I think that this little data, description picture makes a lot of sense. So I don't know if anybody else's folder structure looks like this, but this is what mine used to look like, and still sometimes looks like, if I'm to be honest. So you have, the first version of a document, and then you have version 734A-7. And, there are ways, right, that we can do version control with documents and with code. We can think about things like, Google Docs, where you can go back to previous versions. But Git is a really nice way to do version control when you're talking about code and data, which is something that we all work with as graduate students and also undergrads doing research. So today, this is what we are going to be talking about. And before we dive into Git, GitHub, and version control, I just want to talk a little bit about why GitHub, or why version control in general. And I'm going to send these out at the end of the workshop. UCSB, which is my alma mater, has this great data literacy series where the library just produces these awesome little data graphics. And so I'll send this out to everyone, but essentially the reason you do this is for traceability. So you have all versions of your code and all changes throughout time documented. And so you can document the development of a process or an algorithm or just data cleaning, and you can do that with your collaborators. That's really the power of GitHub, is that you can do version control in teams. Also identity, it tracks all changes made by different users. So if you have a collaborative project where you're working with 12 or 14 co-authors or collaborators, you can track who's made what changes, which is really important and also exciting. And then also efficiency. So using a version control interface essentially allows you to make all of your effort for correction and debugging code happen at the same time for everyone. So for instance, if I asked Claudia to debug code, but we were working on a project with 14 other collaborators, Claudia would push that up to GitHub, and then all of the collaborators would be able to pull down that clean code, and they wouldn't have to do it themselves. And so it's just a really nice way to keep track of everything and make sure that you and your collaborators and future users of that data have an idea of what you actually did and why. So there are lots of different version control interfaces that you can use, but I'm a big proponent of Git and GitHub. And there are lots of reasons for this, but first and foremost, it's open access and it's free. And I'm, as a data scientist, I like to push that everything you can do where it's open access and free is the best thing that you can do. Also, it can be used offline. It works seamlessly with GitHub, which is a really nice interface, and all of these other reasons as well. So that's why we're talking about GitHub today, but every data user has different preferences. So if GitHub isn't for you, definitely seek out other options. Another thing that I just want to talk about briefly is data management. So using version control is only going to be as useful as you make it. So if your folder and file structure is ugly and it's impossible to understand, then it's not going to be a very fantastic repository, right? So you definitely want to be using data management best practices. There's a range of opinions on what these look like. I follow essentially what's happening in this infographic right here. So I have, and I'm just going to decrease the size so that hopefully we can see more of it. But again, I'll be sending this out. So if you can't see it or are having a hard time, you can look at it down the line. But essentially, you'll have a project folder, and we'll be using our projects today to organize everything that we do. So this will become more clear, I think, as we go through this workshop. And then within that project folder, I have a different folder for data. And within the data folder, I always have a raw data folder or an input data folder, and then an output data folder or an analysis data folder. So the number one rule, right, when we're working with data is that you never alter the original data. The original data is sacred and you have to keep it that way. And then, of course, you want to keep your analysis data, your clean data in a different spot, because you shouldn't have to rerun the cleaning code every single time you're working with that data. That should just be sort of a permanent piece. And then you can have a scripts folder where you are actually writing the code to clean the data, analyze the data, visualize the data. And then I always have a results folder for results from models, tables, etc. And then also a visualizations folder. So more and more in science across the board, folks are interested in seeing visualizations and nice ones. And RStudio is a fantastic data visualization software. The next workshop in this workshop series is on ggplot, which is the sort of data visualization package in R, and you can make really, really beautiful maps and other visualizations as well. So that's just sort of the whirlwind project management. Why do we do version control, introduction. And now we're actually going to get into the meat of the workshop. So I'm just going to close out of this, and the first thing that we're all going to do is go to your GitHub page. Okay? So everybody head to your GitHub account, sign in if you aren't already signed in. Okay, awesome. I'm just going to assume that everyone's there. So when you get to your GitHub, you're going to see, your profile. In this overview, it has all of your public repositories. Don't worry if you don't have any yet. And then if you actually click on the repositories tab, you'll see that I have a couple of private repositories, and those are private because I haven't published that work yet. But in most cases, you're going to want to create a public repo. In order to create a repository, you're just going to click on this green New button. So click on the green New button. And then you're going to come to this Create a New Repository page in GitHub. And I'm just going to call this, I'm going to call it Unicorns. You can call it whatever you want to call it. And as a description, I'm going to say this is a test repo. I'm going to make this repository public because I am excited to share my data about unicorns. And then you have these three options at the bottom. It asks you to initialize your repository with a README file, a gitignore file, and a license. You're always going to want to include a README file. So this README file is sort of the bread and butter of your repository. This is the first thing that future users are going to click on and say, oh, this is what this repository is about. And I'll show you an example of a README file in a second. But you always want to initialize that, and then you always want to populate it. That's sort of my #1 rule when you create a repository. And then, oh my goodness. So sorry. And then you're going to want to click Add Gitignore. This essentially adds a file from a template. So we're going to choose the R template because we're coding in R. But there are also templates for Python and for a bunch of other interfaces. And we're going to choose this Gitignore template. We're going to add this file because there are often files that you don't want to cache. And by cache, I mean like save when you're uploading data to Git and also pulling data from Git. So these are things like your R history file. You don't need that or want that. That's just going to gunk up your system. So once you've clicked on the README and the Gitignore, and you've selected this R template, you're going to click Create Repository. And you'll let it think for a second. And now you have a repo. So if you go back, if you just click on your name in this upper left-hand corner, and come back to your overview page, you'll see that your test repo has appeared. So that's fantastic news. You've nailed it thus far. I want you to click on this repository one more time. The next thing that we're going to do is we're going to clone this repository. So I want everyone to click on this copy button right here. It's just going to copy this repository location to your clipboard. And then what I want everyone to do is actually open up RStudio. It's going to take a second because my computer is old. Hopefully your computer doesn't take this long. Okay. finally appearing. It's just going to take a second. Okay. So can everyone see my RStudio now? We're good. Okay, awesome. So now what we're going to do is copy or clone our Git repository into RStudio. The way that we do that is we go up to File and New Project. And once the new project window loads, you'll see a couple of options. So you'll see start a brand new directory, associate a project with an existing directory, or check out a project from a version control repository. So we're going to click on this third option. And we're using Git. So luckily this is built into R, and our GitHub accounts should, fingers crossed, be talking to RStudio already. So click on Git, and then you're just going to paste what you copied from GitHub. So you're going to paste that repository URL, and you'll see that the project directory automatically populates as your repository name. And then here, you're just going to want to choose a subdirectory, so a place on your laptop or desktop to actually house this locally. And so I'm just going to put it in this teaching folder because it makes sense for me, but choose wherever makes sense for you. And then we're going to click Create Project. And you'll see that essentially Git is talking to R and GitHub, and it's pulling all of the data that we created on GitHub down to our local desktop or computer. So now it's going to switch projects. And what's really nice about our projects, if you're not familiar with them, is that they organize data and code in a really tidy way. So when you use an R project, R knows that when you're building code inside of that project and you're pointing to data to clean or to process or to visualize, R knows to look inside of that project folder, which is sweet. So everything that's inside of that project folder is associated with everything else inside of it. And so you don't have to point R in the right direction, which is really, really nice. So now you can see that all we have in this project is this README file and this gitignore file. So that's exactly what we created online. Now I want everyone to create a new file, an R, I guess let's do an RMD. So you can come up to this plus document button, and then we're going to click our markdown. And you can name this whatever you want. I'm just going to call it unicorn analysis. And I really like using HTMLs. So for those who aren't familiar with R Markdown is like the coolest way, I think, to communicate your science to collaborators, to your advisor, to any future user of your data and analyses. Essentially what they do is they turn text, so, written language and code into a document where you can read both at the same time. And the really cool thing about HTMLs is that anyone can open an HTML as long as you have a browser, and most people do, but there are certain people who don't have Microsoft Word, for instance, or who don't have a PDF reader. So I always use HTML. So everyone just title it, and we're going to use a document, and then we're going to click OK. For folks who are familiar with Python, Markdown documents are sort of the same as Jupyter notebooks. And so that's just sort of analogous, if that's helpful at all. You can see that when you create in our Markdown document, there's all this junk in here. This is just telling you what the R Markdown actually does. So you can see that there are code chunks, that this is a Markdown document, that it's a really great formatting syntax that you can transfer into HTML. You can look at data. You can also embed plots. And what's really nice about this is that when you click knit, it'll ask you to save it. And I'm just going to call this unicorn analysis RMD. It will actually create an HTML document. This is only if you have Knitr installed in RStudio. And is there anyone who doesn't have Knitr installed? Could you put like a hands up or a thumbs up? Or if you don't even know what that means. Okay, so that's a package within R. So now you can see there's this like really pretty document that has a plot, and you can look at the data and all this other stuff. So the way that you install a package, you can either do it from the graphical user interface, where you come up and you click Tools, and then Install Packages. And then you can type in whatever package you need. So Knitr is literally just knit-r. And this is the package that you would need to install to create these knitted R Markdown documents. So then you would just click install, it would install, and everything would work out, and you could knit documents and make really pretty documents for your collaborators to read. But that's sort of beyond the scope of this workshop. So now you'll see that in our local repository, so on our computer, we have this new document called unicornanalysis.rmd. But if you head back to your GitHub page and hit the refresh button, you'll see that that's not on GitHub. And that's because you haven't told RStudio to push anything up to GitHub. So GitHub has no idea that this new data exists until you feed it that data. So we're going to go back to RStudio now, and we're going to follow the process for pushing data up to the cloud and then also pulling it back down. So the first thing that you're going to want to do is actually stage your the changes that you've made to your repository. You'll see that there are 5 tabs up top here in RStudio, and Git is one of them. So if everyone could click on Git, you'll see that there are now 3 new things that have either changed or been created within RStudio since we've created this repository. So the first thing is that we created an R project. To stage this, you just click this little white box. And sometimes it takes a minute, but it'll eventually check. And then you've also created this new document. So you're going to want to click everything that's in here. And essentially what staging is just saying, okay, I'm telling R to hold on to this. This is stuff that I want to push up to GitHub, but I haven't done it yet. So we're just putting it in a stage area. The next thing that you do, so the first step is stage. The second step is commit. So you click on this commit tab right here. And it'll take a second. But you see this review changes window. It's going to show you what's been created. It'll also show you this diff window. And you'll see that I'm getting this big exclamation point because I created new documents and Git is like, whoa, 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 you built too much stuff. It's going to be crazy to look at the difference between the two. But this is a really important part of reproducible science and also of version control. And so it's really important to look at the differences that have been made when you're uploading new code. So we'll show a difference in a second, but not right now. You always want to add a commit message. So this is just what will appear with your push to the repository. So you want this to be descriptive, short, and sweet. So I'm just going to say created unicorn proj and built.rmd. But if you are creating a new model or building new visualizations, whatever it is that you're actually doing, that's what you should put in this description. Then you click commit. And it'll take a second, the Git will talk to you, and it'll say, okay, sweet, this is the message that I put along with this commit, and this is what actually happened. So I created unicorns.rproj, I created unicornanalysis.rmd, and I also created the HTML. I'm going to close out of this. Now everything's committed. It's like sitting in this area in between my desktop and the cloud, just waiting to be pushed to the cloud. The way that you push is you click this green push button. And essentially this just means, okay, I'm literally pushing from my computer to GitHub, right? And so when you click that, you'll get this message because R and Git and GitHub are talking to each other. And now you see, okay, we had success. We committed to the main branch. So once you close out of this, you'll see that there's no longer anything staged. There's no longer any difference here. And when we go and we check on our GitHub and we refresh, you'll see that we've added 3 new files to our GitHub repository. So I want to pause here for a second and just do like a thumbs up if everyone has gotten that far. Sweet, lots of thumbs up. Okay, awesome. I need to pause for a second because my computer is about to die and that wouldn't be good. So hold on for 1 second. Everybody in here is good too. Any critiques on how I'm talking about GitHub thus far? Okay. If there are, feel free to just step in. Okay, cool. So we got through like the basics, right? We created a repository, we cloned that repository onto our local machine, and then we made some changes locally and pushed them. But what happens if we create changes in GitHub or a collaborator creates changes and we don't know it? So let's create a change here. First, just in this README, we're going to do it on GitHub itself, okay? So everyone click this edit button in the README file. And I'm just going to add some hashtags, and I'm going to say I am messing with this file. And then I'm going to scroll down. And I'm going to commit these changes. And GitHub actually gives you sort of an automatic option. If you don't add a commit message, then it will automatically just say update readme.md in the commit message. But I'm going to actually type my own message because I think it's good practice. And I'm going to say messed with GitHub. And then I'm going to commit this change. Okay, so now you see this has changed Studio and I click on the README file, it hasn't, right? Those changes are not there. So if I were to make a change to this markdown document, so I want everyone to just scroll down to the bottom of their markdown and just type, this is a test. And click save. Okay. Click stage. Click commit. And it's going to take a second because my computer is very slow. And now you'll see that here we see the change that I made, right? You can see that I typed this is a test into my markdown document. I'm going to write a commit message, which is made change to .rmb. And I am going to commit it. And then I'm going to try to push it. And it's going to think for a second. And then it's going to say, I reject you. And I reject you because your computer does not match what's happening locally, does not match what's happening on the cloud. So this is a really nice thing about GitHub in terms of reproducible science and version control. Like if Mitch and I are working on a project together and I have no idea that he's updated the project and I just go ahead and code and do my own thing and then try to push it, R's going to say absolutely not. Mitch has made changes and you need to pull those down first before you can push anything back up to the cloud. So it gives you all of this information. Essentially what's important is everything was rejected because you have to fetch everything from the main branch first. So you have to pull the data down before you can commit and push up to the server. So what we're going to do now, you'll see right, our commit is already existing in this funny in-between space between our computer, our local machine, and GitHub. We don't have to commit again. What we have to do is pull down from GitHub and update our local machine so that they match. So you'll just click this pull button. And what's really nice is that GitHub or Git, RStudio, does the merge for you. And it tells you how it's merged those files and what it's done. So it merged through the recursive strategy and one file changed and there were 2 insertions. So now if we head to our README file, which remember is what we changed on github.com, if we click here, it should have worked for me too. Ah, there we go. Now it says I'm messing with this file, and I did, and there it is. So now that we have our branch is that it was the same as the one on GitHub. Now we can actually push what we created. And this says, ooh, watch out, your branch is ahead of the origin main by 2 commits. That's because we committed prior to pulling. So I want everyone to push what we've done up to GitHub because it's already been committed. You're going to watch the wheels turn for a second. And hopefully, fingers crossed, we have success. We did. Awesome. So we updated the main branch. That's fantastic news. So now everything on GitHub and everything on our local machine matches. So, and I'm going to send this out in a follow-up email. The steps are essentially clone the repository. copy, clone the repository, make changes, push them up, and then every single time that you interact with an R project, even if it's your own, always pull first. The worst thing that happens when you pull and you don't have to is that you'll get this message. Already up to date. And that's great news, right? That's just a nice reminder that you're working with the correct version of your code. You're working with the most up-to-date files if you're working with collaborators, etc. So the real power of GitHub is its use in team science. And what we would do ideally if everyone here was in person is for us to pair up into groups of 2 and work on a repository simultaneously. That's really difficult to do over Zoom. So I'm gonna have, I think there are just 2 students in the room. I'm gonna have them pair up and do some team science work. And if any of y'all have questions who are on the Zoom, feel free to talk to either Mitch or to Courtney or to Ronan or to Martin and ask those questions. Yeah, unfortunately, it's really difficult. Or I guess we could pair off and do team science with all 4 of you, right? There are only 8 people. How many people are in here? Might be too many. It is totally possible. Okay, we're gonna take a second, everyone in the Zoom room, and try to figure this out. And if it doesn't work, then you can either ask questions or you're free to go. But this is like the bare bones of GitHub, and use it. Like, it can be sort of, the barriers to entry might feel high, but the more that you use it, the more you mess around with it, the better you're going to become at it. And manuscripts and publications more and more are asking for data repositories and code repositories. So it's like the biggest piece of advice that I can give is to start using this like often and always. So I'm going to quick try to figure out breakout rooms, and if we can't figure that out, then I will check right back in, but I'm going to silence myself for just a second. Okay, so we're not gonna do the breakout rooms because that's gonna be a mess. So I just wanna wrap up really quickly. So Martin brought up something that's important to remember. If you're doing collaborative team science, I just want to show you sort of how to do that, and then also one of the pitfalls or one of the things that can be a little bit frustrating. So if everyone could go back to their GitHub page, to their repository. The way that you collaborate is you share. So you go to settings right here, and then you click manage access. And then you can invite collaborators. So you can invite friends, researchers, etc. And after you do, and you add them either by using their GitHub email or their username. After you do this, they will get an email in their inbox where they accept your invitation. And then you can start collaborating together, which is really fantastic. One of the things that can be frustrating is that if you are working actively at the same time on the same code, and then you try to merge them, you can get errors that literally say you cannot merge these files because you're actively working on them at the same time. That's frustrating. You just need to give it a minute and wait for your collaborator to be finished with what they've done, and then you can merge the files. Another thing that is important to be aware of is this git ignore file, which we created but we didn't actually look at. Also, I just realized I'm no longer sharing my screen, so sorry everyone. I told you how to collaborate and then I didn't actually show you. So let me just go back to my repository now that you're actually looking at my screen, and you click settings and then manage access and then add people. Okay, as simple as that. Now we're just going to check out this git ignore file that we created. So you can open this bad boy up, and inside of this git ignore file, it's telling everything that you want it to ignore. So you want to ignore our history, you want it to ignore our data, you want it to ignore the R project user files, and yeah, often this was just brought up by some of the helpers. It would be nice if you could just tell Git what you wanted it to track, but instead you have this git ignore file. So I don't know if any of the other instructors want to step in and say what you add to this. I've only ever used default settings, so that maybe shows that I'm a noob at all of this, but I can mute myself and then y'all can go on your computer if you want and say what you typically add. If you have things to add.
Oh gosh.
Oh no. Okay, can you mute yourself and then we'll be here?
Yes.
Sorry about that.
Can you guys hear me? I think so. Yeah, okay. So I have my Git connected to my entire research folder. So, where I have all of my documents and papers and PDFs and CSV files and everything. And so I don't want, all these picture files and PDFs and document files to be tracked either. It's just unnecessary. It takes up too much space and Git crashes too much. So I basically have everything in my git ignore except for R files, RDS files, and CSVs. So I have, entire folders blocked off, my papers folder, my writings folder where I have drafts and whatever. I have analysis folders where I have my graph outputs and things. I have PDFs, ArcMap files, like shape files and things, like basically anything that's not like an R file or some kind of coding file, an RDS file or a CSV that has very simple like data in it, that GitHub, that for one, that I don't need to track. I don't need GitHub to track it in the first place. And if it does track it, it's just like way too big and too clunky to track. So I just like make sure that that all of that stuff is in Gitignore. And it's the way I use GitHub is different than what Britta's talked about. And I'm not sure how to do it through this method, but like I'll go through like the Git bash in the console and do like Git status to check on what Git is like trying to push. And if there's anything that's like doesn't have that's like a weird file format that I don't want to push, then I will go to the Gitignore and be like, okay, hold on, let me add this file format in really quick, or this like entire folder or something, before I do any like committing or pushing. So I don't know how to do that through your method.
Yeah, through my GUI. Yeah, so Ronan just brought up a really good point, and thank you for saying all of that. What I showed you today is the like graphical user interface way of interacting with Git. I'm gonna send out a link that is a link to another workshop where you're actually going through using Git bash, which is what you had to download in order for Git RStudio and GitHub to communicate. And that's sort of the I don't know, the raw way of interacting with Git and GitHub. And there's a lot of power using Git bash. And I just don't love command line stuff. But as Ronan and Courtney have pointed out, it is a good thing to know. So that's sort of the scoop with those other options. I'm going to send out a follow-up email with all kinds of information. If you have further questions, you can feel free to reach out to me. This is my last day technically as a like Utah State employee, but well, as a Ecology Center employee, but I'll maintain my Utah State email because I'm teaching an MNR course. So feel free to reach out, and if I don't have the answer, I'll ask one of the other instructors / helpers if they have the answer. So thank you all for being here. If you have any further questions, please raise your hand and the helpers will try to address them in the chat. Otherwise, you are free to skedaddle. Thank you for being here.
Thank you, Britta.
I'm going to, how do I turn off my recording?